what's going on? And this is another video for nested fractions of daily math training with Khan Academy using Algebra basics. So here we go with that. I'm not going to really spend too much time. I'm just going to just focus on getting a better score. Okay, so we can go here. We can say which expression is equivalent to. Which expression is equivalent to 2 over b plus 2 over a, 2 over b plus 2 over a, over 2 of ab. So first what we would have to do is we would need to get these two. Let's remember, if we have like 3 over 1/2, we couldn't do this first. We would have to balance them out. So we would do something like this. And then we have 5, 6. So this means that we would do something like a times b, b times b, times a. And then we would give 2a over ba plus 2b. And then you have here 2 over ab. Then we would do the same thing, I guess, for here. Well, actually, first we would do this one first. So we would end up with 2a plus 2b all over, ab. And then we would have 2 over ab. So now if we have this, then we can do the next piece, which would be to pull the 2 out, right? Which would lead us to we have a plus b. And then, so that would be 2 over a. So then we would have that. Then if we pull, and we could pull the 2 out of here as well, but let me see. So we would end up with the 2 over here. The 2 down here would be something similar to. So we would have it's 2 over 2a. You know, everything it says like 2/4, right? And then this would be 2/4. So we would pull that 2 out. Canceling this out would be something we would do. If you did that, we would end up with something like this. But then we would have to go ahead and we would have to do AB. Yeah, and the reason why is because of the fact that the 2a plus 2b plus 2ab would have to cancel. So we would get 2ab on the bottom, we get 2ab over here as well. So that's kind of confusing, but it's something we have to kind of pay attention to. Let's go to the next one. All right. So we have here, which expression of the equivalent is 1 over xy over 1x minus 1y. And then this is kind of the same thing before. We would have 1 over xy. Let me see. Let's say x equals 3 and y equals 2. And we would plug in, first we would have to get the actual numbers properly balanced, and then we'll have a negative 1/6 over here. And then on top here, we have we have 1/6 over 1/6, right? Now, this is kind of like saying, if you had like just in a number, like let's see, 1/6 is like, it's a decimal. So it's like a negative 0.16 something, right? So if we had negative 1/6, that makes it just like one number. So how will we do that? So let's go ahead and remove all of this and try to use the equivalent of this number. So let's breaking that down. We don't flip the numbers. We don't flip the numbers. We just go ahead and we pay attention to the we pay attention to 1 over xy, and then you have 1 yx, and you would have something like, this is kind of a, so you have here 1 over xy, and you have 1 xy, y. So yeah, let's go ahead and let's try to focus on doing this expression by itself. So if I was showing you x equals 3 and y equals 2 for that particular situation, we would have to kind of multiply that by x. So x will end up here, and y would end up over here, and then we would end up with like y over xy minus x over yx, right? For the bottom. You can pull out, knowing that you have xy and xy over here, you can kind of just solve for y minus x, which would be yx over xy for the bottom. Now the top would have the y over xy. So let me make this a little bit bigger. I'm gonna grab this and bring this over here, and actually just make it bigger. So you have y over xy, and then you have yx over xy. Now, any of these things look pretty much the same so far? Probably not. It doesn't look like it. But looking at looking at these numbers here, I'm trying to see which one would be. This y here over xy looks like that because it looks like these would cancel again, because the denominators are actually the same, and we just end with 1 over xy. That's my intuition. Yeah. So there you go. Now let's move on to the next one. We have here 1 plus xy over xy, and we have 1 plus xy, and then you have here xy, and let me see. I'm looking at this. We can see that this 1 will basically become y over y plus xy, which would lead to y plus x over y. And then you have an xy like that. because we have that, we can also do the cancellation of the bottoms like that, and we end up with yx over x like that, not a g, a y. And then that looks like this one down here. Okay, so that's the intuition for the nested fractions, you know, that I'm using. It's just roll with it. So you have 2x over 6 minus y, and then you have here x minus 3 over y plus 1. All right, so now we could start, you know, looking at it. Well, we know here we can plug this out, right? So we would plug out 2. So we plug out the 2. We pull, if we take 2 out of here, you know, like 2 times 3, right? We pull the 2, and you put the 2 over here, right? And then we take this out, and that's basically like 2 times 1, right? And then you pull the 2 out of here like that. Yeah. We don't multiply these together. All we do is we use the distribution of 2 minus x minus 3. Because if we use the other rule where we multiply these back in, we would end up with this number here. So that's good. Okay, now you have y, and then you have x minus 3. And you have y plus 1. So this one down here, see how like now that I did this one here, this looks very similar to that one. So that's great. But now we have this extra one here, which is y plus 1. Now can we cancel the y out? Yeah, we could. We could still do it. So if we cross out these, right, can't make sure they cancel out, we just end up with 2x3 with x minus 3 over 1. And this actually means this. It's just whenever you have a 1 in denominator, it's just like saying that. Then we can go ahead and we can actually cancel out both of these, and we just end up with 2. No, and I wanted that to work. Okay. Okay, so we can't do that. The other thing I can possibly say is the one I guess that I have to go back. Let's go back a few steps. Let's go back to this one here. So let's say we can't cancel that out because you have the y plus 1 here. You can't put the y plus 1 on the top. This is like so I guess like it's like 1 divided by, if you say y divided by the y, you end up with 1, but we have the 2 there. That won't work. So I guess we can probably say these 2 cancel out. That probably still happens looking at these multiple choice questions. And then we have 2 over y with y plus 1 like that. And we could pull out a y. Now leave it 1. And then you can divide y into y plus 2. So if you go y just into y plus 2. I'm lost right now. I don't know. Let me see. Let's see. So since we know the fraction can be interpreted as a division, we can write this as this. right? That's exactly what I was doing up there. Oh, wait, it says, oh, okay. And then we flip it. That's what I should have done, the reciprocal. Right, and that was almost right. And then you end up, after you do the reciprocal, then you can do y plus y. So what was the actual trigger for that? So if you know a fraction can be interpreted as division, we can write this as this. So I should have flipped this because it would have the division of both sides. So that because of that, I feel like now the answer is probably going to be 2 to y. Yeah. Yep. So see how that was. That had nothing really to do with that had nothing really to do with was actually like you had to basically see how you could do it. You know, like it wasn't just like adding and subtraction. You had to kind of like see that problem come up. But now that I have that particular I saw that problem show up, I can retaliate and do a better job next time. So that's great. I'm not going to do too much with that. I just want to make sure that I actually build upon that. That's 20 minutes, right? 16 minutes right there. That's fine. I could work on algebraic expressions quiz 2 and the unit test tomorrow. But one of the things I wanted to do was to have a understanding of what needs to be done so I can react to it. And that just takes practice. Just keep practicing. Everybody has problems like that, you know. If you're, I'm practically like 37 years old. So I did this before, but it was not, I did it, because I had to do it. Now I'm doing it because I have to learn it, because I want to learn it, because I want to do better, I want to do more complex, mathematics. And being able to do simple mathematics is a great way to build on top of more complex mathematical equations and expressions. And there's nothing that could really keep you from doing these things. You can definitely do it if you put your mind to it, and and motivate yourself to to see better opportunities. So that's one thing I wanted to say to you, and hopefully you'll be able to get build on top of that. So take care, and I'll see you guys in the next video. Tomorrow, I'll probably do nested fractions again to build on top of what I learned today. And then quiz 2, I'll work on top of that for everything. And then hopefully Monday, I'll do the unit tests, and then we can move on to linear equation and inequalities. There's a lot of things that have to get done, but I don't think it's going to be that much. It's not really, it's just it's just constant work ethic every single day. Just put 20 minutes into this. Try to do it as early as you possibly can. I would rather play games at the end of the night, and I do my work during the day. I mean, sometimes you can get games in the middle of the day, but I would make sure that the hardest thing I do is at night. I mean, the hardest thing I do is the first thing I do in the morning, when my mind is fresh and I have all the things ready to go. So